Compose Navigation 3 is official navigation library from Google, and since recently it hit stable 1.0 release. It's a fundamental shift in how you work with and think about navigation, and in this series we will cover all the use cases. In this first video we will start by setting things up for Android, and in the second one we'll do multi-platform setup because these two are different, and from there on everything is the same. So we will dive deep and cover all the topics, and by the end of the series you will know everything that there is to know about this new Navigation 3 library. So let's start. I have prepared a simple multi-platform project and added a couple of screens, but first let's just take a look at what are the dependencies that we will be using. So as you can see, we will using the stable Navigation 3 library for Android. For Compose, it's not yet stable. For this version, I'm using 1.10, release candidate 2, and it's using the navigation library that is in alpha 6 stages, but that should not concern you. So these are all the dependencies that we need. I've added all of them. As you can see, I've added all of them, although we will not right now use all of them at once, but it's a nice, I don't want to go back and forth and do the setup. I purposefully did not apply Kotlin serialization plugin in Android, and we'll see why. We are starting from app activity. This is pure Android setup. As I said in this video, we will do the Android setup. If you want the multi-platform setup, go in the video in the description below. But now we'll start from the simplest use case, and then we will move up to more advanced use cases and see what are the benefits that we are getting and maybe some drawbacks that we can get. The main thing about the Navigation 3, Compose Navigation 3, is that it's a fundamental shift in how you think about and work with navigation, as I said before. So navigation is no longer hidden behind the API wall as you had in Navigation 2. With Navigation 3, we own everything. It's a declarative navigation library built for Compose, so it plays very nicely with Compose. And the philosophy is that you own your backstack and you can do whatever you want with it. So we will start with creating our own backstack. So because now we control it, we need to build it. Previously, you had API wall for navigation and it was done somewhere here. You are hitting the API, but now you need to do all of that yourself. Oh, that will be later. Remember, mutable state list of any. This is the bare minimum example that you can do, and as you see right now we are using any. Now that we have our backstack defined, we need to display it somehow, and of course they provide us with a num-display composable that will take our backstack, and we will need to define an entry provider ourselves. So this is for each entry. This entry is your screen, and inside of here you will need to define all the nav entries that you would like to handle. Just to satisfy the compiler for now, when else nav entry, and then we'll have for anything else. As you can see in the file structure here, I have onboarding screens, onboarding 1, onboarding 2, and we'll see how that will work. For the sake of visibility, I will have the screens defined here. Composables for the screens are in the shared multi-platform project, but for the visibility, I will define our actual data classes and objects for screen above the activity, and we will have data object onboarding 1 and onboarding 2 just to showcase how things work. And if our key, because we have any as a type, it can be whatever, and we will check for the onboarding 1. And again, we need to have nav entry for that key. That will be our screen. Just a second, it's complaining. Yeah, when key, right? Okay, and for the onboarding 2, you see already a lot of duplication, but we'll deal with it. So for onboarding 1, we want to display onboarding 1, and as you can see, it has a click handler on next clicked. So what we want to do when we have on next clicked, we want to push onboarding 2 on the backstack. How we do that? We own our backstack, so we will just add it to our backstack. And if we run the app and uh, let, let's see, right now it's crashing. Let's see what the actual error is. So if you see, nav display backstack cannot be empty. We need to define our initial route, so or entry. What it will be onboarding one. This is how you define your initial screens. You can have multiple initial screens depending on what you do, but for the sake of our example, we'll just have this. Right now, this is what we have. On the next, we are adding onboarding 2, but we are not displaying anything yet. And let's display onboarding 2. It has a name that we will handle later. On next clicked and on back clicked. So let's handle on back clicked. So for example, we had how we will add to a backstack, and now let's see how we will remove. Again, we own a backstack, so we can just remove last or null on. And let's see, let's run and see. We have step 1, then we go to step 2, and then again we go back to step 1 again. Because it is very simple, we control our backstack and we can add to it or remove from it as we wish. Now that we have our basic thing set up, we can see that there are a lot of problems with this. We have a lot of duplication. So for every key, we need to define nav entry, and we don't use type safety, passing any, so it can be whatever, and we need to handle it somehow. We are surviving configuration changes because we are using remember, but we are not surviving process deaths, which will be bad if that happens. For example, user is 4 screen deep into your app and then they leave, come back, and they are in a screen 1 again. So this is not ideal. We cannot pass arguments easily this way, etc. And we will solve all of these problems by using serialization library that Compose Navigation 3 is taking advantage of really nicely. So serializable. That's the first thing. The second thing is that we don't want to have this. We want to survive process death. Again, the philosophy of the library is that we own our navigation, our backstack, so we can do whatever we want with it, but they are providing a nice utility functions for this. So we will have remember navigation backstack, and as you can see, it takes nav key as parameters. So our screens will need to extend nav key. You will see why this is important in a second. 26, and we will have onboarding 1 as our initial screen. As you can see, compiler is not happy right now because we are using the wrong override, because right now we are using nav keys and there is a DSL for that. We don't need to do manual things like this anymore. So we can delete all of this, and then we can just define entry for onboarding 1. That will be this, and then we don't need to define else. Then we will have entry for onboarding 2, and it will be this. If we run this, we will get a crash. That is expected, yes. And why we are getting the crash? Because we are using serialization library. As I said in the beginning, I'm purposefully not using it. As you can see, it's complaining because we are not using. So classes are serializable, but we are not using the plugin. So let's apply the plugin and try things again. Copy next, serialization. Okay, the sync is done, and now we will run our app again and see what's going on. We have step 1, then we have step 2 as before. We can go back. As you can see, we are in a working place again, but with a much nicer API surface than we had before. Let's take a look at why this is surviving configuration changes. So as you can see, they are using something called remember serializable, and here lies the key for the differences between Android and multi-platform setups, implementations. On Android, they are using reflection, so it's easy for them to grab all nav keys that we have. using reflection and create serialization module. For this, you need to know how serialization works with polymorphism, closed and open. But on the non-Android platforms, this is unsupported, and we need to register our own serializer module for our keys. And we will do that in another video. But basically, they are remembering, serializable, and it is using, remember, savable. If you are familiar with it, it is using saver, which is the way to survive configuration change in Compose world. It is the equivalent of getting a bundle after the activity's recreation after process that. It is using saver, and they save it. But when process dies, when process is being restored, this is, they uh, restore it. So that is why it survives configuration death and process death, configuration change and process death. It is the equivalent of, having saver is the equivalent of having, handling this one, but in a compose oriented way, and it has much nicer APIs than, accessing bundles as they are. With type safety, let's see how we will handle passing parameters around. And for that, you may already noticed that we have in our entry lambda that we are getting the screen that we are, to pass. We are getting it, so we can extract whatever there, we need from it. And here we will just make it a data class, because on step 1 we want to enter some name here and then pass it, and we will have a name. We don't need a name here, but we need a name here, because we will provide name from screen 1 to a screen 2, and it is asking us for, we cannot just, it is asking us to create an object nicely. And I will expand this so you can see type inference, hints, and it will be the name that we enter here. If we take a look there, it's very simple. We are just remembering the state and passing that name that user enters to a next screen. And if we want to extract it and not show AA, but actually show the name that user is passing, we will use it dot name. Let's run it and see it in action. So we can have name, and that will be hello name. We can go back and have name. It will be hello name. So whatever we pass, we will have here. I did the rest of the setup for this. I basically just created onboarding 4 and onboarding 3. On the onboarding 1, we will enter our name. On step 2, we will enter last name. On onboarding 3, we will display the full name, and on onboarding 4, we will complete the onboarding. Very stupid onboarding, but it has a purpose. I do not want to make you sit through a setup. So basically, onboarding 1, we are passing the name. Let's have it as a name. Onboarding 3 is taking a last name. So it's taking full name, but right now we are passing on the last name. So our full name will be onboarding 2 name plus last name, and we will be passing full name here. And on onboarding, on going to next, we will have backstack, add onboarding 4. And on onboarding 4, when we are done, because we own our backstack, we will do something crazy, and we will do backstack.shuffle. And because now we can, in navigation 2, it was pretty hard to do this, but now you can just do shuffle, and we will shuffle the screens. And let's run and see what we have so far. So it will be name A, last name B, AB, complete. Step 4, shuffle, who knows what will happen. We have screen 3, then we go back to 2, to 1, Okay, just shuffle them nicely, but if we do again complete, when we do done, we're going straight back to step one. And now we don't have a back button here, but the rest of those are in there. So that was just to showcase that we can do whatever we want with our back stack. We can actually uh, set up so the screens know where they are in a hierarchy. So on back clicked, we can have this um, either as a nullable and then check if on back clicked is not equal to null, then we will show the navigation icon, and we will do the same thing for every other onboarding that we have. So for 3, we'll also do that, and we will make this nullable. We don't need to make it so it's a null by default. Again, here we'll just make it nullable, and we will need to do the same thing here. I will just remove this so it's consistent, and we need on back clicked that can also be nullable. It is complaining. Of course. Okay, and because now it will not run because here we need to define what happens on back press. So it is on next clicked. We will do this, and on back clicked, we will do the same as with everything else. Backstack, remove last or now. That concludes our first video in a series about Navigation 3 library. We are done with Android setup. We saw how the most basic use case would look like, and then we moved on to this type safe approach that survives configuration death and process death, configuration change and process deaths, and we saw why that is the case. So in the next one, we'll see how to do a multi-platform setup, and after that, we will dive into transitions, into providing a view models for each entry, because we don't want our view models to be scoped to the nearest activity. We will be building our own adapter for this, same as the Hilt is doing, just to see how it works under the hood. We will do that for the Kotlin inject probably, or maybe even new Metro library. I'll decide on that one when the time comes. But yeah, see you in the next one. Thank you.